Hello and welcome to PowerPods. I'm Matt Alsop, Digital Marketing Manager for Hubbell Utility Solutions Power Systems Division, and also co-director of Saving Skylab, America's First Space Station documentary. You can view the documentary at savingskylab.com as well as YouTube. On this episode, we'll be talking to Chuck Lewis, a Marshall Space Flight Center veteran who joined NASA in 1967. Mr. Lewis left his mark on most of the nation's human spaceflight programs, Apollo, Skylab, Spacelab, and the International Space Station. As a young electrical engineer, he was recruited by von Braun's Crew Systems Group to contribute to the development of the extravehicular activity film retrieval system for Skylab, and during the mission served on the Crew Systems team that successfully saved the wounded space station, developing the Skylab thermal shield, the EVA techniques used to erect the damaged solar array, and other in-orbit repair schemes. Following a stint in Marshall's propulsion division, he was selected to serve as payload training coordinator for the Spacelab 1 mission, STS-9, and ultimately supported that mission as the Science Capcom in the Payload Operations Control Center. After Spacelab 1, he was promoted to the Chief of the Manned Systems Integration Branch, supervising engineers and support personnel in manned systems requirements, payload operations training, and real-time support of manned space missions. Then in 1994, he was chosen as the Chief of the Mission Training Division, responsible for flight crew and ground support training on Spacelab and Space Station science payloads, as well as manned systems design standards and requirements. After retirement in 1997, he assisted the Japanese Space Agency Space Station training team as instructor evaluator, astronaut surrogate, and coach during Japanese payload training rehearsal certification sessions. Chuck and his wife Janelle live in Huntsville, Alabama, where he volunteers at the U.S. Space and Rocket Center, mentors a high school robotics team, and continues a lifelong interest in amateur radio. Welcome to the podcast, Chuck. Are you there?
I am here. In fact, I'm sitting in my ham radio ham shack.
All right.
And it's kind of like a man cave.
Great.
I don't have, I'm a bit of a gearhead, so I don't have a horizontal surface for putting anything down. My notes are sitting on top of the laptop of the keyboard, and I got a cup of coffee on the very corner of the desk here.
Great.
And as long as the cats don't come up and knock it off, we'll be good.
Awesome. Well, first I just wanted to say on behalf of Hubbell and Wes, thank you so much for helping us with this story. We knew that there were some deeper ties to it out there. We, had to dig a little bit to find them, but obviously you are a key part of this story, so we appreciate your help with it. Well,
I feel like just pretty much the storyteller. I've been telling this story every chance I had since the real thing happened, because I think it's the best human interest story that I know of from the mission. But, in all likelihood, this is just one of dozens, if not more.
Yeah.
Because there's so many people working on it, and everybody's got a great story. So this one just has the kind of components in it that spoke to me, and I hope it'll be of interest to other people as well. Seems to be every time I've told it, people love it.
Yeah. Going back to, I guess, when David was doing research for the book, how did he get in contact with you, or how did he find out about what you guys were doing at the time on the mission? How did that come about?
I remember getting a call from Owen Garriott. Owen, as you know, was one of the crew members on Skylab, and Owen and I worked together on Spacelab a number of years later. But Owen lived here in Huntsville, and by the way, we lost Owen last year. That was just a terrible loss. A wonderful, wonderful person and great representative for American spaceflight in the country. But I remember getting a call from Owen, and he kind of outlined what they were doing and asked whether I might be interested in coming over and talking about my experiences. And I think he remembered the A.B. Chance story, because I'm sure I told it to him more than once. He probably got tired hearing it. But they had set up a 3 or 4 way conversation with Joe Kerwin, and Owen invited me over to his house, and David was there, Owen was there, Dr. Joe was on the other end of the line, and it was very much like what we're doing here. Owen kicked it off, and they were recording, of course, with a little desktop recorder, nothing sophisticated. And we just started kicking it around, and when I started the story, I just kept on going with it until it was done, and they had a couple other questions. But the really nice thing about that and about the entire book is that David and Owen and Dr. Joe as well managed to get all of that stuff from everybody they interviewed. I think they did that maybe as a primary data gathering method. But if you read the book, you can easily see that these are pretty much dead quotes. The authenticity of the book is not compromised. It's not somebody else's opinion. It's all straight from the people that were there. It was kind of fun. Yeah. And then the book came out later. And a number of years after that, I get a call from, or get an email from you, and I suppose that David gave you my contact information, and that's how you got me. Is that right?
Yeah, that's right. So just to let everybody know, we're talking about the book Homesteading Space by David Hitt and Dr. Joe Kerwin.
I should have said that.
It's out there and available, and Owen Garriott was also one of the co-authors on it too. So if you haven't picked that up, it's a really cool read. It's very thorough. He covers a lot in there. So if it's not in that book, it probably didn't happen.
I thoroughly agree with you. It's a wonderful reference, but it's also an interesting read. It's pretty engaging.
Yeah. So let's go back in time a little bit. What were you working on before the Skylab mission?
Well, that's a really interesting it's a really interesting question. I had only been working for NASA for I don't know, maybe a year and a half, something like that. I started right out of school at Boeing in Seattle working on antennas. I'm an electrical engineer, and I went out there from Detroit, where I grew up and went to school, Detroit Institute of Technology. Boeing was working on the Minuteman program, and that seemed like a fun thing to do, and I got involved in testing some of the X-band antenna systems. That was interesting. It was a wonderful place to be, and in fact, I proposed to Janelle and suggested that we would go out and live in the Great Pacific Northwest. A short time after that, the Boeing management came around recruiting for Huntsville. It seems that Minuteman was phasing out, and Boeing's involvement in the Saturn V program was growing, and they needed people down here. It was a tough decision, but I liked the idea of working for the civilian space program, and it looked as though there were some pretty good opportunities down here and some fun stuff to do. I'd always been a science fiction fan, and that just was kind of right up my alley. So I had to call Janelle and say, guess what, honey, we're not going out to the Great Pacific Northwest after all. We're going to Huntsville, Alabama. And there was a bit of a silence there, but it all worked out. It's been a wonderful place to live and grow up, and so we're still here. That was in 1963. So I started out working at Boeing and worked on the Saturn V program, working at the telemetry ground station, where we were checking out the first two stages, getting ready for static firing here at Marshall. So I got to climb around in the engine bay all over those F1 engines, checking out transducers and signal conditioners and doing a lot of really fun electrical engineering stuff. And after that slowed down a little bit, I heard about an opening at NASA and switched over. It was in an electrical networks area, very, very close to what we had been doing with the Saturn V first stage checkout, S1C. In the middle of that, a friend of mine, whose name is Dick Heckman, came over and got talking about what he was doing at NASA, which was some human factor stuff, developing tools and techniques and human interfaces for primarily for astronauts and other users too. And he and I had been doing some sports car racing together. I was a pit crew on his team, and also wound up doing some other stuff in an administrative position. So I guess he felt that I had some operational background and that I might fit into that group. And we got talking about it, and he said, "Why don't you see if you can get transferred over to our group? It's a whole lot of fun." So that's how it all started. And right at that point, we were working at that time, and after I joined the group were working on Skylab. We had a lot of things to do on Skylab. Some of us were working on some of the experiments, still human system interfaces. Some of us were working on Apollo telescope mount, the solar telescope that was part of Skylab, particularly working on the control panel, which was pretty much autonomously operated by scientists, astronauts in Skylab. And then our job, two or three of us in our little team, worked on developing the EVA trail that was required in order for the crew to get the cameras back from the Apollo telescope mount. Several times during each mission, the camera canisters would run out of film, and they would have to go out and do an EVA, retrieve the canisters, replace them with fresh ones. And there were a number of them, and they were all in different places scattered around the ATM. So the challenge was to come up with a routing, and which involved handholds, foot restraint, umbilical routing procedures, foot restraints at the workstations where they would actually pull the old cans out and replace them with the new ones. These were, by the way, bread box and larger size. They weren't little cassettes. They're pretty big. A lot of them used big photographic plates. That's pretty much what we did up to Skylab launch. I guess then the rest of the story begins there.
So in the documentary, you talk about the safety concerns, the safety considerations that you have to make. Just retrieving the film from the telescope, it didn't sound like they had really ever done that before, or have to constantly make EVAs out to retrieve film, or even to go outside of the capsule. Were there any other previous missions that you had to work from to figure out how they would make those treks?
Well, there were some difficult times in the Gemini program where several, at least one for sure, EVA was tried, and primarily we think because of lack of foot restraints, that was less than stellar. A lot of thought went on about how to make things easier for the crew and safer as well. And I should say at the start that Marshall was involved in this because our center had responsibility for the Skylab part of it. JSC in Houston was really busy getting the shuttle ready, and so Marshall was chosen as kind of the lead center for all of that, which meant that we got involved in some crew stuff, which was traditionally the responsibility of Johnson in Houston. So we were kind of following the lead of those guys down there, but had a reasonably good relationship with them and kept that fairly friendly all the way through that whole process, even though there was a good bit of rivalry going on at the time. So none of this was done in a vacuum. We realized from the start that the only way that the crew could actually do good work was to have a foot restraint, and we came up with some ideas, did some brainstorming, sent them down to Johnson. They countered with some other designs and approaches, and ultimately they came up with the final design for the foot restraint. And in fact, that's what was used almost unchanged up through the Hubble era. But then we also had to worry about potential for umbilicals to get snagged by structure. One of the things that you always need to worry about with a pressure suit is a puncture. So you go through the design and build a mock-up, simulate it in 1G, simulate it in 0G, and the KC-135 aircraft, where we get about 25 seconds of weightlessness, and in the neutral buoyancy tank, where the crewman and his suit can be balanced out to be neutral in the water. It doesn't rise, it doesn't fall, and it doesn't take any particular preferred orientation. It takes a little while to do that, and the swimmers that do that, divers, do a marvelous job. We don't do that at Marshall anymore, but Johnson does still. And all three of those simulation modes gave us a wonderful opportunity to try some of these things. And of course, when you were looking ahead for potential problems, you really have to kind of go through it in your mind, much as an athlete runs through a sequence of whatever they do in the game. I guess the thing that we got pretty good at, got pretty proud of, was the ability to put ourselves in the position of the user and evaluate the design with brutal objectivity and do it over and over and over again, looking for all those problems.
Yeah, David talks about it in the documentary. We kind of take things for granted today because we have history to build off of. But, Skylab was the first for a lot of the issues, humans being in space for an extended amount of time, potentially have different issues than, say, a mission for a day or two and they come back to the Earth. So, it's amazing to me hearing you talk through this. There is something to the point that a lot of this hadn't been done before. And for you guys to be working through those in a way that you really didn't know necessarily what was going to happen in most cases, and to be able to think about those issues, because we kind of bring it up in the film, and you had a document that you showed us where you kind of listed out all of the things that could potentially go wrong and what you could and what you couldn't fix. And obviously you guys went back on one of those because you did have to fix it. But, that forethought of trying to figure out what you could and couldn't fix was really important in this case, and probably moving forward in all the other missions to come. I'm sure that all has to happen during some point. Yeah.
There were a lot of other fixes too. One of them in particular that I think people could relate to, because it's kind of in everybody's history one way or another. We had this is back on Skylab. We had an issue with a component called the Charger Battery Regulator Module, CBRM. It was kind of the traffic cop between the solar arrays and the loads that were fed by the current developed in the solar arrays. So this guy had a bunch of relays in it, and thinking back, compared with today's technology, this is pretty mundane stuff. Real mechanical relays and stuff like that. And it was about 10 or 12 inch by 10 or 12 inch by maybe 7 or 8 inch box. It was in a spot where we had already decided to put a foot restraint, which was going to be the one that the crew was going to use when they deployed the Marshall solar sail. We knew that the crew was going to add that foot restraint, and that might be a good spot to fix the CBRM. Well, what the CBRM was doing was it would just go offline. So we got on the horn and talked to the designers, the detail designers for that CBRM, and we said, "You guys ever run into this in the laboratory? What's going on? What can you tell us about it?" And they said, "Yeah, I remember every now and then we'd get a relay to stick. Contacts would get, and it happened with a couple of the early test units, but never did after that, and we declared it okay." It tested even, after all the vibration and thermal stress testing and everything, which is extensive. And I said, "Well, what did you do to fix it?" And he said, "Well, we hit it with a hammer." And I said, "Well, where did you hit it?" And he said, those screws around the cover that hold the cover down, they're socket head cap screws. He said, "You'd find the one in the lower left-hand corner and count up 2 screws and give it a quick wrap." And we said, "Okay, well, we'll work on that." So we thought about it for a while, and again, got permission to ask the crew to do it. And sure enough, during one of the other EVAs, I don't know whether it was the one that played the sail or not, but that was a long time ago, Matt. Anyway, he had a hammer from the crew, the tool complement, which was really, really small, by the way, and gave it a good bang, and it fixed the son of a gun. And the guys on the ground were ecstatic, and they whooped and hollered, and we got current going back again. So that's with all this sophistication and all of the parts that have to go right, you can expect that from time to time something is going to go wrong.
Yeah,
and for a lot of us, things we remember is are things that smack of shade tree engineering. Good old measure up 3 inches, hit it with a hammer.
Yeah, brute force.
Brute force.
Yeah.
But at that point, you, as we learned in the film, you don't have any other choice. You've got what you got, and you have to make do with what's on board and what the guys up there and on the ground can come up with to make it work.
Yeah. I wanted to transition a little bit into the timing between Skylab 1 launch and the Skylab 2 launch. So obviously the initial plan was to send up the crewed mission Skylab 2 the day after the launch of Skylab. Obviously that didn't happen. And then 10 days later they launched. And then there were some days between that second launch before they actually did the EVA to fix the solar array and to deploy the parasol. I guess Give me a sense of that, what was happening in those 10 days prior to the Skylab 2 launch.
I guess anytime you get bad news, the mantra, first there's denial, and you know all the rest of the steps. So I guess we heard about the problem, we were probably just initially numb, trying to figure out what in the world could have happened. We started doing some brainstorming, and we had a little separate room in our office complex that we had set aside as we called it a war room. And we had the IT guys, they weren't called IT guys then, set up a link with audio from the air-to-ground loops we tapped into between Skylab and Mission Control. But we also had access from there to the crew quarters at the Cape, where the primary and backup crew were in somewhat of a quarantine. And we were able to talk back and forth occasionally with those guys and compare notes. So we were doing a lot of brainstorming. We had a little model of the whole Skylab cluster, and we were stringing strings and toothpicks and paper clips all over that thing. Really, just thinking about everything. Nothing was rejected. Everything was fair game. Throw it out on the table and see how everybody reacted to it. And that was probably the first day or day and a half. And nobody wanted to go home. I was working, and I think everybody else did. We worked till we dropped, and then we went home for 8 hours. So it came to 30 hours on and 8 hours off. And just to give you a sense of how it was, I got my wife to bring a sleeping bag out. And that first night, I slept under the conference room table in the area where we had our big Skylab mock-up. J.R. Thompson, whose picture is there in the film, did the same thing in one of the other modules that had some habitation. I think there were some cots in there. Anyway, everybody was doing that. Management was walking behind us saying, what do you guys need? Money, manpower, need an airplane, what do you need? And I remember J.R. Thompson, again, answering a question from the press. They were, for some reason, they were feeding him all this stuff. And whoever it was, whatever reporter it was, obviously asked him, what are you guys doing? And Bob said, well, the better question is, what are we not doing? We're doing everything, which means we were thinking of everything we could possibly do. All the contractors were not only thinking about stuff, but actually building it overnight. I mean, just crash, no holds barred, get her done. Later on in that 10-day period, when we had some better ideas about the kinds of things we thought we might be able to do, somebody had to start designing. And of course, all drawings and designs have to go through a lot of vetting and drawing checking and all that kind of stuff. So those kinds of things that would take weeks traditionally were being done in minutes or hours. Organizations that were previously rivals were suddenly great friends, walking down this path hand in hand. So there was a lot of simultaneous stuff going on while the guys were doing their final designs. We were taking crude versions of what they had done and running through those procedures in the neutral buoyancy tank and in 1G. While we were doing that, we're still in our minds going through and doing exactly the same things that I discussed earlier, thinking about the actual process and procedure. You can't help but do it. It just runs through your mind like a broken record.
Yeah.
And that drives a lot of issues out. So all during this testing and verification period, which was just a matter of days, changes were coming fast and furious. So one of the big challenges there was to be able to react to some of those changes. Some of them were major, some were minor, and to be able to anticipate what we needed. The bottom line that we all remember is that everybody was working as hard as they could, and all of the barriers that you normally have in a normal production design development, production testing process were just thrown out. We did what we needed to do, and we're ultimately able to convince management that it was safe. We had a lot of help from the crew. At that point, the backup crew was there, and they were able to show that this was something that they could do, even though it was challenging, something they could do that it would work.
Yeah. So obviously 30-hour days can be pretty stressful. What'd you guys do to, kind of relax the environment, or was it all strictly business? Obviously this was a very important mission to NASA and in the future. But what'd you guys do to blow off steam?
This little team that we had was really a bunch of mavericks. We had a whole bunch of different people from a lot of different disciplines, and it was not the traditional kind of thing that Marshall Space Flight Center was used to doing. To some extent, we were misfits, and even though everybody after the fact, we got a lot of props and pats on the back for doing all that, but we had a lot of very creative people. We put together something called the Bioastronautics Research Foundation. If you think about the acronym BARF, it was open to anybody who had experienced all three forms of in-orbit simulation, simulating the microgravity environment. So if you'd been in the water tank, if you had flown on the KC-135, which was called the Vomit Comet, if you had participated in 1G simulations as well, you'd had done all three, and you qualified to be a Barf member. And what it really was a way to kick back and laugh from time to time. So we made it as funny as we could. We sent a letter to Phyllis Diller asking her to be our Barf queen, and in fact got a really nice one back. It took a little while, but we got it back, and it was full of typos and misprints and strikeovers and corrections in pen. So we know that she did it.
Wow.
But it was a lot of fun. So we had every instance of a Barf organization was called a bag. So we had bags in Huntsville, Houston, most of the contractor areas, and even a couple in Europe. And mainly the idea was it was just an excuse to go out and after work and let everybody enjoy their beverage of choice.
Nice.
I remember, not just on Skylab, I remember getting in deep trouble when we were getting ready for Space Lab. I know we're bouncing around from one mission to another. Maybe it'll make sense. Close to launch of Space Lab, those of us who were involved in as ground controllers for the payload operations, which was all the 72 science experiments on Space Lab, would go down as we got closer to launch and run some simple simulations from the Payload Ops Control Center, which was on the same floor as Mission Control across the aisle. Had our own little room there, but it was same kind of thing that you normally see. Lots of consoles, people sitting there with their heads bent over the consoles and doing whatever they do. And we had been having a lot of trouble with the air-to-ground loops. It really wasn't an issue that was going to crop up during flight because these in that particular case were simulated links. The real connectivity wasn't being used in, but it was really frustrating for us when we were trying to do a sim and we couldn't talk to the crew. So a couple days before we were due to head back, I think for one short week's respite before the launch, and I think maybe it was a delay. We'd been kidding about the issues with communications, and I got two foam coffee cups and a length of string, and I tied a knot in each end of the string. You know the drill. You hold the coffee cup. Yeah, I hung them on the back of the console and put a little sign on there that said "Air to Ground 1," and everybody got a real big kick out of it.
That's awesome.
Well, what I didn't know, is that the next day, the alternate shift, we were still going around the clock, 2 12-hour shifts. During the alternate shift, after I put that little device up there, was an open house day for the press.
Oh.
And that little picture of the two coffee cups wound up in one of the Houston newspapers. And needless to say, my center director was not very happy.
Wow. That's a great story.
But we were able to defend it on the basis that we were so strung out at that point that we just really needed that kind of thing, and it helped. And I guess sometimes you just have to cut everybody a little slack.
Yeah, right. Yeah, that's great. Wanted to kind of switch gears a little bit. We started trying to come up with ways of filming this documentary and trying to understand the story of A.B. Chance and now Chance Lyman Grade Tools, and really trying to dig into understanding, how Cliff Bosch was involved. He was our product manager at the time, and you guys reached out to him. Was there anything that you took away from the film that maybe you learned that you didn't know necessarily before about us or about the other side of the story?
Yeah. One of the big ones came from you, Matt. I remember, if you think back to the story itself, we talk about making that first cold call and having the first guy that answered offer to send a catalog. And I thought at the time, when I was on the phone with that guy, I thought, that's really funny. It would make a really good stand-up comics pattern. And then, of course, he sent me on to the next guy up.
Yeah.
And I've thought about that. I've used it as a humorous part of that story for years. But I didn't realize until you told me that catalog is an integral part of A.B. Chance culture, corporate culture. They're dearly proud of their catalogs. They make a wonderful catalog. And then this guy was obviously bought into that culture and was going to make it work, my gosh.
Yeah.
Then the next thing you said, when Cliff offered to come down to Huntsville to help with this, that was yet another part of A.B. Chance culture, where the idea that we're not just going to sell you a tool, we're going to help you use it, teach you how to use it. So another a closure for me that explains Cliff's actions at that time.
Yeah,
and I always wondered what was going on back at the ranch, because the only interface we had was with Cliff himself. So, we were all imagining, my God, is Cliff's boss yelling at him to, record all this stuff? We gotta send an invoice. And what about Cliff's wife when he called back and said, honey, you'll never believe where I am.
Yeah.
Please pack a bag. And so a lot of that stuff just filled in a lot of gaps for me.
Yeah.
I'm just a storyteller here, and Cliff and Chance are the heroes, but I feel a lot more fulfilled now having heard all that background, that backstory stuff, and it just makes a whole lot of sense. And I guess the other thing is, over the years when you start telling a story and it gets embellished, we never do that, right? It's always the other guy who does the embellishment. Well, I got worried about whether I was embellishing too much, and it was really great for me to be able to hear it from the other side and realize that I really hadn't embellished it too much. That
right.
What we said happened really did.
Yeah.
So it's just been great.
Yeah. Yeah. It's pretty amazing. Chance Lyman Grade Tools is still an industry standard. That catalog, it is changed over the years, but it's still, for every electrical lineman that's out there, they know that catalog. They usually have it in their truck when they're out in the field fixing somebody's, line or getting power back on. So that's a big deal. And we also have several lineman trainers that travel constantly, go around the world training lineman crews. So it's still very much part of our Hubbell Chance Lyman Grade Tools culture to continue that service and make sure that we're helping the linemen day to day, because they are our first responders in our industry to get power back on.
I've got a connection there that I've not told you until now, which is again some closure. One of my favorite uncles, Kenneth Norcross, was superintendent of Sherrard Power Company, a small power distribution company in northern Illinois, just east of Moline. And whenever we'd go out to visit relatives, occasionally he would take me with him on the truck for half a day or more, and we'd go out and run lines and talk to the crews. And so that's more closure.
Yeah.
Ken was just a sweetheart, and so my basic understanding of linemen is extremely positive, and it comes from that experience that I had with my uncle.
Yeah. So, just wrapping things up here. It was great talking to you, getting in a little bit more detail about some of the stuff that we couldn't fit in the film, but wanted to make sure we got some info on. What do you want people to take away from the film?
Oh, there's a bunch of stuff. I guess maybe through some of this, you'll get the impression that NASA folks and the contractors that support them are real people. We have challenges and stresses and successes and failures, just like everybody else. And sometimes we mistakenly think of NASA engineers as somehow being elitist or up there on a pedestal or whatever, and that's not true. We're just normal folks trying to do the job. And the neat thing was that, talking about stereotypes here, it's so easy to think of the lineman as a lunch bucket guy, and here we have two disparate cultures that aren't all that far apart in reality, but may be perceived by some as being a wide gulf between the two. Here they are coming together. The linemen come along and help bail out NASA and do it with great enthusiasm and no charges. And to me, that's an example of what happens when we perceive a common adversary and all get together to defeat that adversary in a get her done attitude. That's something that Americans pride themselves on, and there was no better example than that kind of thing. It wasn't just chance either. It was all those other companies. Some were contractors that we were paying. Others were contractors that had but maybe wished they had no straight contact with NASA for that particular program. They were still doing everything they could to help during that 10-day period. It was an amazing time, and maybe it's a good example for what we're going through right now. Everybody getting together and rival organizations and competitors becoming friends and walking hand in hand down the road. Yeah. Like to see that as much as we could. So it's kind of timely that you guys decided to put this film together, and nobody could expect that we'd run into what we're up against now, but it sure seems to be relevant.
Yeah, absolutely. Chuck, again, thank you so much for helping us with this. We really appreciate it. It's amazing to me that when you got involved, we had no idea that you had as much of that story contained. You had the note that was put on your desk, some of the other documents and pictures. We just appreciate it so much and helping us tell this story. That's obviously super important to NASA, but also important to us here at Hubble. And just want to thank you.
When all this was happening, I remember thinking, this is historic. Not just what was happening around me, but everybody, everything that was going on is historic, and there's not enough time for anybody to document it.
Yeah,
that was just a real disappointment. But and so I guess that's why I kind of threw some of those papers in a folder, and they stuck with me through to retirement. And here we are, years and years later, and you guys have managed to collect all those pieces and put them together with help from David and Bill's family and the Smithsonian and a bunch of other folks too. And it's a real nice way to tie the ribbons on all of that. So thank you for closing a part of my life. I've enjoyed every minute of it.
Awesome. Thank you. Well, we'll definitely get back to Huntsville and grab another beer here in not too long. It seems to be our stomping ground straight to hell. Got to get back and get some of those ribs.
It works for me.
Okay. Well, thanks so much.
Let us know.
And we'll be in touch. Thanks for listening to this episode of Power Pods. And if you haven't seen the film yet, please go to savingskylab.com and view the full documentary. Thank you.